Hello, this is Mr. Waters, and here's another video from page 806 and page 807, and this one has to do with infinite geometric series. Infinite geometric series. And we're going to do two things with infinite geometric series. First off, we need to determine whether the series is whether it is a divergent series or a convergent series. And if it is convergent, which is actually the kind of geometric series that we're interested in, we want to find the sum. So right here, if convergent, find sum. And this is actually pretty easy. So first off, what do we mean by a infinite geometric series? So that could be a geometric series like, I don't know, this one. 1, 2, series, right? 1 plus 2 plus 4 plus 8 plus ... Now, the thing is that this is if it's an infinite series, it keeps going forever. Okay? Where the number of terms, or specifically, there are an infinite number of terms. Okay? So there are an infinite number of terms in the series. Now, previously, when we found sums of series, we only found a specific sum, a specific value as the sum of the series if there were a finite number of terms. Like if we took this 1 plus 2 plus 4 plus 8, if the series just stops at 4 terms, then yes, we can add those 4 numbers and we get a sum. A specific sum for that. That would be 12 plus 3, that'd be 15, right? Well, here's the thing. How do you get a sum if there's an infinite number? If there's an infinite number of terms in that series, how could there possibly be one exact number that adds up to? Well, the answer to that is sometimes there are and sometimes there aren't. And here's what you need to know. If the series is divergent, and we'll find out what that means in a minute, then there is no sum. And we leave it alone. We say, it's divergent, so there's no sum, so we can't do anything with it. If it's a convergent series, and we'll find out what that means in a minute, then there is a sum, for which there is a formula, and we use the formula, which we'll get to in a minute, to find the sum. Okay? Now, so how do we know if the series is divergent or convergent? First off, let's just focus on the fact that it is that we are talking about a geometric series here only. Okay? Other kinds of series might have sums also, but in this case we're dealing with infinite series, but we're dealing with geometric only. So, and as I said above, it is the convergent ones that are going to have a sum, the divergent ones that do not. Well, what you do in order to find out if it's divergent or convergent is you figure out what the R value is. Okay, you look at this series and you calculate, or you figure out, or you deduce what the R value is. Okay, if the R value is in this interval from -1 up to +1, notice the soft brackets. So we're not including -1 and +1. If the R value, in other words, is a fraction between -1 and +1, then it is convergent and it has a sum. Now the reason why we call it convergent is that the values of the sequence zero in or converge at a particular value. So that's why it has the sum. If our value is not in this region, if it's not between -1 and +1, then the series is divergent. And what that means is that the values of the sequence, the sums of the sequence, zoom infinitely out of sight, get larger and larger and larger and larger, and they don't converge to any particular value, so there's no exact sum for the series. Okay? So anyway, so let's say we've got, so for example, this sequence or this series we had up above that I started with 1 plus 2 plus 4 plus 8 going on forever, you can see in that one, let me switch colors here, you can see that the R value is equal to 2. R is not in that range, not in the -1 to +1 interval, so therefore this is divergent, and that series will not have a sum. So we just leave it alone. We go on from there. Okay? On the other hand, what if we had a series that looked like this? 2/3, 4/9, 8/27, and really I should write this in series form, shouldn't I, rather than sequence form. So let me erase that and put a plus and put a plus there. Oopsie. Erasing the paper too, that's interesting. Put a plus there, dot, 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 and that keeps going forever, right? Fever, forever, for short, okay? So we look at that, and maybe you can see that the R value is 2/3, okay? So the R value, the common multiplier in that series is 2/3. That is in the -1 to +1 range, and so this series will be convergent and will therefore have a sum. Okay, so we'll just see what to do about that in a minute. Or you might be given the series in this form here in sigma notation from 1 up to infinity, and notice that the little infinity sign there is instead of the n. That shows it keeps going on forever. And let's say it's -3/4 to the n. Okay, it might be written that way. You can see that that's a geometric series where -3/4 is the common multiplier. So R is equal to -3/4. That's also within the -1 to +1 range or interval and so forth. That series will also have a sum because it is also convergent. Alrighty, so how do we actually find the sum? Well, that's the easy part. We use this formula. The sum of the infinite geometric series, that's supposed to be an S there by the way, is equal to G sub 1, the first term in this series, over 1 minus R. So our first example here, where R was equal to 2/3, 2/3 was the first term in the series, and then 1 minus 2/3 on the bottom, because 2/3 is also the R value, or I'm sorry, I'm getting ahead of myself, 1 minus 2/3 there. So this is 2/3, where 2/3 is the R, you see. 2/3 over 1 minus 2/3 is 1/3. 2/3 over 1/3, of course, is 2. And so this series, that series right there, would have a sum of 2. Now, it's not kind of 2, it's not close to 2, it's exactly 2, which is a little factoid that you would prove in calculus, why that's exact. Now, the second one, okay, the infinite sum here is going to be G sub 1 over 1 minus R. So in this case, we need to calculate what g sub 1 is because it's not given. That's going to be negative 3/4 to the first power, which is, negative 3/4. So again, the r value and the g sub 1 value are the same. So I put negative 3/4 up on top, like that. And then 1 minus negative 3/4 on the bottom. So that's going to be negative 3/4 on top. 1 minus negative is, I believe that is, we add the opposite, 1/4 plus 1. That's going to be 1 3/4, right? So that's going to be negative 3/4 over 7/4, right? And so we multiply by the reciprocal to simplify it, just like that, cancel, cancel, and we get the 4's cancel out on top, and it looks like we get negative 7/3 is the sum of that series. Alrighty? Okay, and again, that is the exact value. So that's how you find the sums of infinite geometric series that are convergent. Thanks.